I've clicked onto the Global Tropical Overview for May the 8th, 2024. As is always the case in these videos, the subject's pressure are mine alone, and in making decisions ahead of any tropical cyclones, look to the Local Weather Office, Local Emergency Management, and Local Tropical Cyclone Warning Center. So we have one system active across the tropics today, and this is going to be more of a long-range discussion of formation, as the system is nowhere near developing. But I'm also going to pair this with my updated 2024 Atlantic hurricane season forecast. So that's going to be in two parts for the video, and I'll leave a timestamp to that if you want to skip ahead. But we're going to focus on what's going on now, and we've got an invest in the West Pacific, the first, technically the third one of the West Pacific season already. The Joint Typhoon Warning Center has issued, or not issued, but marked 90W and 91W, and now they're gone, and now what remains is 92W, which is just in this mess of thunderstorms that you see on your screen here. Very confusing with invest numbers. I'm sure it's going to change around maybe a bit more. Maybe we'll talk about a completely different invest number next time I talk about this West Pacific system, but who knows. But the most important thing is that this system is looking more and more likely to be developing at some point within its lifetime in the West Pacific. We talked about last week how we were going to watch towards the West Pacific as we get into early to mid-May for potential tropical development. And we're starting to see signs on models more into closer range now that we could actually see that happen. One thing that you can see already is what I talked about last week, the westerly wind burst coming along the equator. You can see in the low-level clouds. It's a bit hard to see on this, but there are some low-level clouds moving out of the west along the equator. And if you look north there, we've got east winds north of all this convective mass here, and this is aiding a broad but general area of cyclonic spin, which in the northern hemisphere is counterclockwise. And this is going to help aid the system as it tracks slowly towards the northwest over the next few days. Now, as of right now, this system is not, like I said, not anywhere near forming into a tropical cyclone. The center, if you will, looks to be about here. There's a little tiny spin there, but also it's very close to the equator, and that will likely change at some point. I wouldn't be surprised if maybe something else tries to form with this massive thunderstorms, and if that dissipates, another low could form. So we're likely to see a lot of lows form within this general mass here, but eventually it will be moving more northwest towards the Philippines, which is off the screen here, but it's in this part of the map. And once it gets up there, the environment will likely be more favorable and we'll likely see tropical development take place at that time. But it's going to be a slow process, and that's good news here for those in the Philippines who may be concerned about the storm. We have a lot of time to watch this. This is a GFS ensemble plot showing you each member of what it thinks is going to happen with the storm. So as it moves northwest, you can see all these red numbers here are currently in the Invest 92W when it's actually close to the Philippines. And you can see immediately there's not all too strong of guidance here or support from the GFS ensemble. And this has been an interesting trend. If you go back to several runs ago, we actually had way more guidance supporting the system developing east of the Philippines. And what exactly has caused this? It looks like maybe a difference within the westerly wind burst. If I go back in the prior runs, you can see the westerly wind burst was a little bit further north. So we had this cyclonic belt of background vorticity or spin further north, where now in the most recent run, it's much more kept to the equator. And this is as the system is now east of the Philippines. And this is more in line with the European model. You can see the European model has a very similar zonal wind anomaly plot, and it's more consistent on this. So maybe this is a GFS trying to go more in line with the European, and the European also looks fairly similar to the GFS ensemble member-wise. Now, this does not mean that the overall chance of the system developing has gone down. The environment is still very favorable. You can see, if you look at the upper level wind plot from the GFS, we've got a lot of divergence here. You can see in these streamlines with these arrows, they're just diverging away from where the system would be at this time. And I'd still say that odds are pretty decent here that we get tropical development here. And if we look at the European model, which is more now similar to the GFS, it still has a lot of significant tracks here and more members showing potential for development east of the Philippines. Now, in terms of where the system could track, Right now, it looks like there's two main scenarios for this system. If it remains a weaker storm, it's likely going to face more of the steering flow from the trade winds, which is going to likely put it into the Philippines. If it's stronger, it's more likely to go out to sea because we have a big upper trough that's forecast to dig in over the region, and that will pull it out to sea. And of course, in that case, you'd hope for a stronger storm than to avoid the land entirely, but there does create a little bit of danger there. You can see in some of the ensemble members, we have the storm coming in as a weaker storm, and then maybe it intensifies as it gets close to the landmass and then starts to recurve. And that could be a danger there. And that's really why this system bears some more watching in the Philippines. It's not an imminent threat. Like I said, we're days out. We're over a week out from development of the system. But it's something to monitor for the Philippines. And it's a reminder that it's May now, and we're getting into that time of year where this may become more common as we go through the summer months into the fall. But the West Pacific is not going to be the only place we're watching over the next couple of weeks. You can see on the Climate Prediction Center Outlook, they've got two other areas marked in the week 2 time frame, which is May 15th to May 21st. One in the East Pacific, which we talked about last week, that could absolutely still develop, and we'll talk about that more in the future. And we could also see some development in the Bay of Bengal. Not much guidance on this right now from what I've seen, but if guidance does increase, we'll talk about that more as well. And into week 3, they do still have the West Pacific marked, which could be 92W if it takes a little bit longer to develop. And you can see that if it remains weaker, perhaps we could be talking about impacts further west if we do see a weaker solution with it following those trade winds. But that's 3 weeks out. We've got a long time to watch 92W and all these other areas of interest. And as of right now, we have no imminent forming tropical cyclones. We're still in this sort of a lull in the transitional period between the southern hemisphere and northern hemisphere. On a quick note with the southern hemisphere, it does look like for the most part we're going to be done with the southern hemisphere. We did have an invest in the southern hemisphere near Indonesia, 91P, yesterday, but that system has since moved to shore and it doesn't look like it's going to develop much anymore. And I don't see any signs right now of any more tropical development. So as for the southern hemisphere, the season ends, I think, in the southwestern Indian Ocean on May 15th. I think in the South Pacific and Australian regions it's already ended. I think right now it's fair to call it fairly over. Could you still get an out-of-season storm? It's possible. It's always within the realm of possibility. But as of right now, I don't see many significant signals for any more tropical development in the southern hemisphere. From here on out, I think until, say, fall time, springtime in the southern hemisphere, we're going to be focusing on the northern hemisphere. And that would make sense as we're getting into mid-May here. And now with us getting into mid-May, we're getting much closer to the Atlantic hurricane season, the East Pacific hurricane season as well. That starts on May 15th. But that's not the focus of my updated forecast today. I'm focusing on the Atlantic today. I may have a Pacific one if I decide to. But the Atlantic hurricane season begins in about 3 weeks on June the 1st. And I decided that this month I would go through my April forecast, and I'll show you my April forecast again just to give you a refresher of what I had forecasted. But I went through what I talked about last month and revamped the forecast a little bit, changed a few things, and have gotten myself a more updated forecast, more to what we're seeing in climate model trends and what we're seeing in real-time trends as well. So we're going to go over some of the important points that I talked about last month. It's very important that I go over these because I'm not an official agency. I do not represent any official agency when I make this forecast. This is just my personal thoughts on what may happen during the hurricane season. And the official outlook from the Climate Prediction Center will come out in late May, probably about 2 weeks from now. They usually do it about the week before the Atlantic hurricane season begins. The second point is that hurricane season predicting is an inexact science, and it is extremely difficult for me to tell you exactly how much activity we're exactly going to see. That's why you'll see pretty much every forecast give a range of tropical storms, hurricanes, and major hurricanes, is because it's just so difficult. And what's important is that you don't focus on the exact amount of activity, because keep in mind, an inactive season to where you get, say, well below average activity could still be a devastating year overall. It just takes one storm to hit your location, and that's a historic season for you, even if overall it wasn't too impressive of a season. I think 2022 overall, it was a below average season. We didn't reach the average amount of accumulated cyclone energy, though I think in tropical storms we were just about average. But even with that season being not extremely active like the prior 2 years, we still had devastating storms hit Canada and the United States and Puerto Rico and Florida with Fiona and Ian. And that made that season historic, even though it wasn't the hyperactive hurricane seasons that we had in 2020 and 2021. Those are important points I got to get out of the way. Another one, as I make this video, it is Hurricane Preparedness Week, May 5th to May 11th. The National Hurricane Center runs this every May. And during this week, they post stuff on their social media sites, and they're even this year trying out YouTube live streams of how you can prepare for hurricane season and what you should have in your preparedness kit. And they also have this link here that you can see in the center of your screen. This is a permanent link. This will be active even after Hurricane Preparedness Week. So even if you want to look back at this in August, say during the peak of hurricane season, just to review your hurricane preparedness kit, just in case a hurricane comes at you in peak season, this link will still work. And this link has great resources on how you can prepare and what you need to do ahead of a hurricane. All right, with that out of the way, let's go ahead and get into the forecast part now. I'm going to show you the April forecast first. This is what I forecasted last month. I had 18 to 22 tropical storms, 8 to 12 of those storms becoming hurricanes, and 3 to 7 of those hurricanes becoming major Cat 3, 4, or 5 hurricanes, and an accumulated cyclone energy metric of 160 to 200, which for those who are unfamiliar with that metric, that is a basically quality of hurricanes. It's a metric that measures hurricane intensity and longevity. So it's not a weak 24-hour tropical storm that was in the middle of nowhere. This was more a long-tracked hurricane that tracked across the Caribbean or the entire Atlantic. It tracks more longevity of hurricanes, the quality of hurricanes, and it can be in some ways a better metric to measure hurricane season activity. With higher ACE years, you can get more significant activity like in 2017, 2005. And in less ACE years, you could get not as many impacts. Think 2013, that's a very low ACE year overall, and we didn't really have too much activity that year. And that's compared to the climatological average from 1991 to 2020 of 14 tropical storms, 7 hurricanes, 3 major hurricanes, and 123 units of ACE. So what I like to do first of all when going through hurricane season forecast is looking at the current sea surface temperature anomalies throughout the world. As most of the world where we look for tropical cyclone development is water, as you can see here where I'm highlighting with my pen. And the waters usually hold in heat much more and much longer than the atmosphere does. So large-scale patterns that you see in, say, May and June are likely going to hold themselves in place throughout the peak of hurricane season. That's why it's such a good tool to use. And immediately, and this has really been the case since last year, the thing that really grabs your attention is just the amount of warmth within the tropical Atlantic. You can see very warm waters relative to normal west of Africa into the Caribbean. And this is a very big sign of an active hurricane season already. Even if you had an El Nino year like last year, it's still a sign of an active hurricane season. We had an active hurricane season last year, even though we had a stronger El Nino out in the Pacific. But the difference between this year and last year is the Pacific is a different configuration now. We now have a La Nina developing across the equatorial Pacific, that being where you have colder anomalies relative to normal across the entire equatorial Pacific. Now, right now, we're in the transitional period. We're in a more neutral state right now. We're not really El Nino nor La Nina. But over the coming months, this will likely transition full on into a La Nina, as you can see some of the blues already popping up. And there's a lot of cold waters beneath the surface of the ocean. And immediately this becomes a very clear sign for an active hurricane season. And I can show you this in historical ways as well. If you take the anomalies in Nino 3.4, which is about that region that I marked there in the Central Pacific, and the AMM, or the Atlantic Meridional Mode, is what it's called, which is basically these waters here west of Africa. If you compare these two anomaly areas together and you take the difference between the AMM and the Nino 3.4 region, you can get this graph. And this is just comparing how anomalously warm or cool the AMM was compared to Nino 3.4 to ACE of any given Atlantic hurricane season. And what you want to focus here on is the red dots, which is what we have this year with the AMM warm and Nino 3.4 going cold. And you can see that we have a very large area of these dots active hurricane seasons. There are really only two examples of hurricane seasons that did not live up to this expectation, that being 2013 and 1970. You'll see more mainly on 1970, a bit more in this presentation, but you can see the general consensus is from this data set is that we have generally active hurricane seasons when you have the AMM warm and the Nino 3.4 region cold. And this makes sense if you think about it, where the convection during hurricane season is going to tend to focus where the warmest water anomalies are during hurricane season. And if you have a warmer AMM and a cooler ENSO region across the Central Pacific, you have all this warm water focused here across the tropical Atlantic, and it allows the Atlantic to take up most of the rising air, which is favorable for thunderstorm development during the peak hurricane season. And that allows more hurricane development and allows you to get more of an active hurricane season. Whereas if you have the opposite, where the Nino 3.4 region is warm and the AMM is cold, you have more of the warm water across the Pacific. It focuses there and increases wind shear across the Atlantic and makes an inactive hurricane season. Now, these aren't the only two things that we look at. They're very good indicators of what a hurricane season could have, but there's also other ways you can look. One way is looking at the North Pacific anomalies. You can see here that we've got a very prevalent negative PDO pattern persisting. This has persisted for about 4 years now, with the very warm waters, anomalously warm off of Japan, and this cold horseshoe of water. This has not really been prevalent in past years, but this is more of a classic negative PDO look, where you have a negative horseshoe of cold waters along the west coast of North America. And these two patterns, the negative PDO and La Nina, usually mean very active for the Atlantic, because you have lots of cold water relative to normal here in the Pacific, and you really just do not allow it much of a chance to compete for rising air and tropical activity, and you really give the Atlantic all of its potential for an active hurricane season. Alongside that, one more thing that we look for is the IOD, the Indian Ocean Dipole, and I'll touch more on this in just a bit when we get into climate model forecasts, as right now, well, we're still in more of a more neutral phase, it looks like, on this plot. But going into climate models, we've had a few trends over the past few months as we've gone through the spring, now almost into summer, meteorological summer that is, and now we're going to go through some of these trends. One that you see is the ENSO region here, the La Nina, has trended a little bit weaker on these runs. We've now seen a lot less deep blues across the Pacific, and you may wonder, is that a good or a bad sign for the Atlantic? And really, it doesn't really matter if you have stronger El Nino, stronger La Nina or a weaker La Nina here across the Pacific. They're both very favorable for the Atlantic. Though some research may suggest that a weaker Nina can be a little bit more favorable for the Atlantic. One theory I have about it is that typically in a weaker Nina, which Ninas are measured by the Nino 3.4 average. So if you have a weaker Nina, you can tend to have more colder anomalies east here, closer to South America. And my theory is that this causes a lot more sinking air, unfavorable for thunderstorms in the East Pacific, focused here in the eastern part of the Pacific Ocean, which focuses all of that higher pressure across this region of the world, which allows the East Pacific, or really does not allow the East Pacific, to compete at all for tropical activity. And you really focus the westerly anomalies, which usually slow down the trade winds in the Pacific, or the Caribbean rather, and you even decrease shear further across the Atlantic. So in that way, this is more bad news for the Atlantic in terms of not wanting an active hurricane season. The weaker Nina may actually be working against us in this. But that's not the only thing that we've seen trending. We've also seen the MDR, the main development region, which is the Caribbean off towards the coastline of Africa. We've seen this in some models trend warmer. It's hard to believe, but it is trending warmer on these model runs. You can see the very deeper shades of red showing up across the Caribbean there. And I don't need to tell you why that's more favorable, as the sea surface temperatures are fuel for hurricanes. And if you have warmer anomalies, you can have more strong hurricanes. And even if they're more deep, extending more with depth, which you could have with warmer anomalies at the surface, you could have the potential for multiple hurricanes to go over the same area with virtually little tapping into cooler waters from beneath the surface. Now, one last thing on this is the IOD. I talked about this again on the real-time plot. And models have been trending in the past couple of months into a more positive phase of this. A positive phase is where you get negative anomalies along the equator west of Indonesia and warmer anomalies in the Arabian Sea west of India. And this is not normal for a La Nina. You usually have more of a negative IOD pattern showing up, which is why and you'll see this in a little bit with velocity potential plots, you'll see a lot of rising air focused across Indonesia. Whereas in a positive IOD scenario, you could focus that a little bit further west. And this is bad news for not wanting an active Atlantic hurricane season, because that focuses it over Eastern Africa, which that's where a lot of the tropical waves begin to develop that move into the Atlantic and eventually become tropical storms, hurricanes, major hurricanes. And you can increase the amount of tropical waves or increase the amount of possible storms that could develop across the Atlantic in a positive IOD pattern. And that's the climate model trends. But of course, in models like I talked about last month, you only trust them so much. Of course, they can get things wrong. And in hurricane season forecasting, one of a very common thing that we do is we look at history and we look at what years are similar to oceanic patterns, climatological patterns that we're seeing this year. And these were my April analog years. I had 2010, 2020, 1998, 1995, 1964, and 2007. And what I've done is I've completely redone this list. I have looked through years that instead transitioned from an El Nino to a La Nina in the summer and fall months, rather than a strong Nino into a more moderate Nina, as we're seeing weaker Nina trends on models. And I looked through this since 1950, and this gave me a lot more options for analog years. And this also gave me a realization about some of these analog years that I had in April. 1964 and 2007 are now marked as bad analogs overall because of their Atlantic configuration. They're actually pretty poor overall. And now I've had 2 slots to fill, and throughout all the years that I looked at, the best 2 years that I can see that fit are 2005 and 1970. And those have been added to the analog list for this month. And you can see these are in order from best analog being 2010 to the worst analog being 1970. And we're really going to focus on the top 5 here, 2010 to 2020. 1970 is an analog for the year, but I mainly chose it because of the Pacific pattern. The Atlantic pattern is actually pretty poor in 1970, and I'm sure there may be other years that had more of a neutral ENSO state that may be more better than 1970 overall. But we're going to focus on the 5 of the top 5 there. So that leaves 2010, 1998, 1995, 2005, and 2020, which a lot of you may remember. A lot of these years are actually quite active in the Atlantic. In fact, every single one of these Atlantic hurricane seasons are deemed hyperactive, where it has more than 160 units of ACE within the entire Atlantic hurricane season. Just one thing before we go into the comparisons of maps. This is just all the analogs that I had here, and you can see all the poor analogs and weak analogs that I marked there throughout the years from 1950. But these are all the sea surface temperature anomaly plots from August to October of each analog year, and I've marked them with years at the top. You can see, for the most part, every year has good aspects similar to this year. 1970 is the exception, though, with the Atlantic configuration being a little more less optimal, with more of a negative AMO pattern showing up. But you can see a lot of these years feature a La Nina with a negative PDO, warmth off of Japan east of there, and a warm tropical Atlantic, which is what I was mainly looking for in these analog years. And if we average these out, you can see that the overall plot of the top 5 analogs is fairly well matched to what we're anticipating this year, with a warm tropical Atlantic, very warm tropical Atlantic at that, with the colder Pacific signal and warmer off of Japan. And you can also see the velocity potential map there, showing all the rising air across Indonesia, and even an increased rising cell across the Atlantic. And you'll see that in closer views in just a moment. And I marked these again so you can see there's the ENSO signature, there's the Atlantic signature, there's the PDO signature, and there's the IOD signature, which this is not really what we're expecting this year. This is more of a negative IOD, but admittedly, there's not many years that you can find with a La Nina and a negative or positive IOD. So this is the best that we're going to get, unfortunately. But add on maybe some points with the rising air maybe being a bit placed further west because of the positive IOD pattern that we're seeing shaping up this year. But now what I've done is I've focused some of these composite maps over the Atlantic so you can see them in more detail here. And you can see the sea surface temperature anomaly plot on the left, very close to what we have this year. And I have 2024s for comparison just a little bit. And you'll see that this is actually really good compared to this year. And it's really close to what we have having this very focused tropical heat in the MDR from the Caribbean off towards Africa. And the right plot, this is basically moisture anomaly, showing you where you could have more rainfall relative to normal. And this could be used to figure out where more hurricanes are tracking during an Atlantic hurricane season. And you can see a big anomaly in the Caribbean, and this is consistent in other plots as well. If you look on the right one here, this is the mean sea level pressure across the entire Atlantic. And you've got lower pressure there across the Caribbean and Gulf of Mexico and into the Western Atlantic east of the U.S. Coast. And that's very troubling because that could be hurricanes tracking into areas close to land. And a lot of these years in this analog package did show that. Now, one thing I do want to note is that you see a lot of those lower pressures across Atlantic Canada. This could be a mix of tracks going up there, maybe up tracking into Atlantic Canada. But I think what's really happening there is there was a lot of more lower pressure aloft. You could see the 500 millibar height anomaly plot. We had more troughing over Atlantic Canada, and I think that's what's contributing to the lower pressure overall over Atlantic Canada. And a lot of these anomalies are showing tracks coming towards land in the Caribbean and towards the east coast of the US. You can also see in the left plot here the rising anomaly that I showed you on the bigger plot, showing you a lot of potential for MDR activity. That means tropical waves forming well early into their lifetime and tracking potentially across the entire Atlantic for a week plus. And you can also see the Pacific pattern in this right plot here on the La Nina averaged out between all 5 years. But here's the comparisons to this year, as it's important to not only focus on what could happen this year, but also comparing to see how these analogs are doing so far this year. And you can see they're doing fairly well. We've got the warm tongue of water from, say, Spain and Portugal all the way down to the Caribbean islands. That's consistent on the analog package. Same with the 500 millibar height anomaly. This looks fairly similar compared to 2024 with a low pressure more over Bermuda with the negative NAO pattern across North America, which helps warm the sea surface temperatures across the tropical Atlantic. And you can also see the winter pattern was also fairly similar between the analog package and 2024, with a lot of warm anomalies across the northern US and eastern Canada. And the winter pattern can, in some ways, lead to changes in the Atlantic hurricane season, believe it or not. It does all connect in some way. Now, that's how the analogs are comparing to this year, but the main question, of course, is where are these storms going to track? And of course, it's May. We're months out from peak of hurricane season. I can't tell you exactly where any storm is going to form or track, but we can take guesses from some plots that we're seeing in the analog package. And this is the mean sea level pressure anomaly plot that I showed you just a moment ago. And you can see where hurricanes may track just based off this. We could have, again, long track storms that form off the coast of Africa, and they either go into the Caribbean, Gulf of Mexico, off the US East Coast, maybe recurve a little bit, maybe around Bermuda, go up towards Atlantic Canada. Those are some of the tracks that we may see here. And you can also see this correlate well to the relative humidity, or precipitable water rather, anomaly map here. And you can see that little points in the central Atlantic where it sort of spikes up towards Atlantic Canada, which could be indicative of maybe some storms recurving out to sea. And overall, just given this analog package, my thoughts for hurricane tracks this year remain about the same. Again, long track storms potentially going into the Caribbean, and those could go into either Central America or the Gulf of Mexico with time. Storms that may be already in the main development region and may recurve, may go up towards Bermuda or Atlantic Canada, or storms that, rather than recurve in the Central Atlantic, make it all the way out to the West Atlantic and recurve fairly close to home in the US, and recurve and potentially are threats to the US East Coast or Atlantic Canada or Bermuda. And we also could be looking at potential development off the US East Coast. And I'd also point out some more development potentially in the Caribbean itself. We could have a few homegrown systems in the Caribbean as well that develop, particularly in, say, early parts of the season and latter half of the season when you have more cold fronts coming through the area. You could have some more close to home development there. But now finally getting to the numbers of how many storms we could expect. This is the sheet that I use to compare activity of all these hurricane seasons, and you can see they're very active overall, each having at least 14 storms or higher, which is the average. 14 is the average, and above that. And you can see the average of the top 5 analogs is 22 storms, 12.4 hurricanes, 5.4 major hurricanes, and around 200 units of ACE. So I've done this, I've looked at all this data, and this is my updated forecast for the Atlantic hurricane season in May. Now calling for 19 to 23 tropical storms, 9 to 13 of those becoming hurricanes, and 3 to 7 of those hurricanes becoming major hurricanes, category 3, 4, or 5. And accumulated cyclone energy index has been raised a little bit on the upper end metric from 160 now to 220, as we are looking at increasingly likely for hyperactive activity here in the Atlantic. And you can see those again compared to the 30-year average from 1991 to 2020. Very above average in all metrics here. And I'm getting probabilities of an active hurricane season about 80% here. So very active hurricane season ahead. And I will update this sometime in August. So thank you all for watching this whole presentation. Stay prepared for hurricane season. And remember that it's Hurricane Preparedness Week. And it's never a bad time to prepare for hurricane season. And I'll leave the link at the top of the description so you can click ahead to that and go right to that page and get all the information you need ahead of hurricane season. That's all for now. Thanks for watching.